Assalamualaikum warahmatullahi wabarakatuh, and hello everyone. Welcome to the first video on Advanced Construction Materials course MKAE 1043. When we talk about civil engineering constructions, there are several types of material that can be used, such as soil or earth, rocks, timber, steel, aluminium, glass, and so forth. Even though there are several types of materials that can be used, the emphasis in this course will be on geosynthetics. Before I elaborate further on this geosynthetics, let's take a look at some examples of materials that can be used in civil engineering construction. These two photos show the typical scenario at civil engineering construction site. The construction activities shown in these two photos are among the processes that must be undertaken before we can see the completed structure or building as shown on the background of this photo as well as in this photo. Let's take a look at some examples of the materials. First, let's take a look at soil or sand, which is being used to construct roads or highways. And this picture or this photo shows aggregates which are normally produced from the crushing of rocks. And this photo shows the utilization of rocks in the slope stabilization work. This slide shows the photos where timbers are being used to construct or to build houses, something like this, or to construct timber structure, where we can see timber is being used as the column as well as for the roof system or for the roof trusses. In this photo shows timber being used as door panels, and this photo shows timbers are being used to construct bridge. This slide shows photos where steels are being used, for example here, to construct electric transmission towers. In this picture, steels are being used as the columns as well as to form the roof system. This picture shows that steel beams were being used to build this pedestrian crossing bridge. This slide shows two photos which show us the utilization of glass sheets as the glass panel here, or door panels here, and here window panels. In addition to that, we can see that aluminium are being used as the window panels and as the partition panels. Right, those are the examples of some materials that can be used in civil engineering construction. Now let's move to geosynthetics. As I mentioned previously, the emphasis in this video will be on geosynthetics. So there are several subtopics that I need to explain related to geosynthetics. One is introduction to geosynthetics, then major functions of geosynthetics, and lastly for this video, the types of geosynthetics. As an introduction to geosynthetic, let's take a look at the definition. The definition is given by ASTM D4439. Geosynthetic can be defined as a planar product, normally in the form of sheets, manufactured from polymeric materials, used with soil, rock, or other geotechnical engineering related materials as an integral part of a human-made project, structure, or system. So please take note the important terms in this definition. One is planar product, as I mentioned previously, normally is in the form of sheets, something like this. Manufactured from polymeric materials. Polymeric materials normally produced from plastic industry based on hydrocarbon. And then these materials are being used with soil or rocks. The application of geosynthetics in civil engineering field are vast. The geosynthetic material can be used in transportation or highway engineering, geotechnical engineering, environmental engineering, as well as hydraulics. This photo shows the use of geosynthetic materials to form retaining structure for the slope stabilization work. This photo shows the use of geosynthetic materials as shore protection, and this photo shows the utilization of geosynthetic materials in road construction. Now let's take a look at the reasons why geosynthetic materials receive wide acceptance among civil engineering professionals. Number one, high quality control. Geosynthetic materials are manufactured in factory where the properties, the characteristics, and the quality of the products are strictly controlled. Reason number two, geosynthetic materials can be installed rapidly. Since geosynthetic materials are produced in factory, such as shown in this photo, normally the products are in the form of sheets and rolls. So those products can be transported to site easily and can be installed quite rapidly. This photo shows the process of installation of geosynthetic materials using this excavator. Reason number three, geosynthetic materials generally replace raw material resources. In certain civil engineering projects, raw materials such as soil, sand, or rock might be necessary to be used as field materials. These natural resources normally are obtained from borrow pits located at some distance from the project site. With the existence of geosynthetic materials, the natural materials can be replaced. These two photos show the use of geosynthetic materials, which are in the form of block here, being installed to replace natural materials such as earth, sand, or gravel. In terms of performance, these geosynthetic materials may perform similar to those of natural materials or may perform better than those natural materials because the geosynthetic materials, which are basically a plastic material with the characteristic and properties and quality are uniform and controlled. So the deterioration in terms of the characteristic or the properties of these geosynthetic materials can be negligible compared to natural material like soil. The properties of soil may deteriorate with time and environment. Right. Reason number four, geosynthetic materials generally replace difficult designs using soil or other construction materials. Again, if we design using soil, especially clay, we have to take into account the change of properties of the clay due to the environment as well as time. In addition to that, the properties of natural materials are not uniform and we cannot control their properties and the quality. So sometimes the design using natural materials is quite difficult. Therefore, with the use of this geosynthetic material with the known properties, and then the properties are uniform and the quality are guaranteed, so the design using these geosynthetic materials are much easier compared to the design using natural materials, especially soil. Reason number five, geosynthetic materials generally cost competitive against the soils or other construction materials that they replace. The initial costs when we use these geosynthetic materials could be slightly higher than the cost if we use natural materials like soil or sand or gravel. However, in the long run or long term, taking into consideration the cost for maintenance and repair, using geosynthetic materials could be cheaper than using natural materials like soil, sand, or gravel, because as I mentioned previously, the properties of these geosynthetic materials, which are based on the plastic industry, so the deterioration of this material could be very, very small or can be neglected as compared to the properties or deterioration of soil or natural materials. By considering the initial cost and cost for maintenance, I would say that the use of geosynthetic materials could be cheaper than using natural materials. Reason number 6, geosynthetic materials are being actively marketed and are widely available. There are hundreds of geosynthetic manufacturers around the world, and each manufacturer produces different types of geosynthetic products. So there are a variety of geosynthetic products that we can choose from. In addition to that, since there are hundreds of manufacturers around the world, the products are widely available. At the same time, normally geosynthetic people are very active in marketing their product. So those are the reasons why geosynthetic materials receive wide acceptance among civil engineering professionals. Since there are hundreds or maybe thousands of geosynthetic products, so the function will be vast. However, in this course, I divide the function into 5 groups. First is separation. Separation is referred to preventing mixing of adjacent different materials or soil which may occur during construction or may be caused by repeated external loading during the operational phase. So let's take a look at this photo. We can see that this is what we call soft cohesive soil, clay or silt, and then we can see geosynthetic sheets are being installed, and then coarse material are placed on top of these geosynthetic sheets. So the purpose of these geosynthetic sheets is to separate between the coarse material, sand or gravel, from soft cohesive soil below the geosynthetic sheets. The second function is what we call reinforcement. By reinforcement, it means that geosynthetic materials is able to increase the bearing capacity of soil by providing tensile strength as well as by redistributing the stresses. Again, if we refer to this photo, we can see that this heavy machine can work on top of these geosynthetic sheets and coarse material without sinking, because these geosynthetic sheets are providing tensile strength to the soil as well as redistributing the stresses. If we refer to this typical diagram, which shows the variation of stress against strain, which are obtained from the compression test on soil sample. There are 4 conditions of soil samples which are subjected to a compression test. Sample A here, normally soft cohesive soil, without any inclusion or without any reinforcement. And then sample B, with the inclusion of reinforcement, which is one placed immediately below the top surface, and another one is placed immediately above the bottom surface. For sample C, similar as sample B, with an addition of reinforcement in the middle. For sample D, one reinforcement element is placed slightly below the top surface. Another one is placed slightly above the bottom surface, and then additional 2 reinforcement elements being placed in the middle of the sample. Right. Normally, when this soft cohesive soil subjected to compression stress or compressive stress, it will fail with the formation of a failure plane, which is diagonal from the left here to the right here. If the sample is undisturbed sample and good quality sample, so the failure surface will form an angle of 45 degrees. Let's take a look at sample A. When the sample is under compression, as the stress is increased, the strain also increase, and then at certain point, when it reaches the yield point, or it reaches the strength of the sample, then the strain will continue to increase without any increase in stress. That is the shape of the graph obtained from the sample A. For sample B, when the sample is subjected to compressive stress, the curve produced from this test is similar to the curve produced from sample A, because the location of the reinforcement are unable to arrest the formation of failure plane at this region. However, for sample C, with the additional reinforcement in the middle here, we can see that the curve obtained as the stress is increased, the axial strain also increased. After a certain point where it reached the yield stress, then the strain will continue to increase with the reduction in deviator stress or compressive stress. So the increase in stress or strength here is due to the additional reinforcement element in the middle here, which provide what we call internal confinement. So this internal confinement tend to increase the strength of the soil. For sample D, we can see that as the stress is increased, the axial strain also increase, okay, until a certain point, beyond which the strain will continue to increase without any increase in stress. If we compare between curve produced from sample D and curve produced from sample C, sample D produce a higher stress or higher strength. This higher strength is achieved due to the inclusion of these 2 reinforcement elements. These 2 reinforcement elements produce additional internal confinement, so that the soil sample gains higher strength as compared to sample C. So those are the concept of reinforcement when geosynthetic materials are being used together with soil. Function number 3 is filtration. In this case, geosynthetic materials allow seepage from a water-bearing layer, but at the same time, this material prevent soil particles from being washed away or carried away by the flowing water. So let's take a look at this schematic diagram. Let's say this is a golf course, and we have sand bunker here. At the bottom of this sand bunker, there's a subsoil drainage system, consists of a perforated pipe here, and then a drainage system consists of what we call aggregate or gravel with high permeability, and these aggregates are being wrapped or encapsulated by geosynthetic sheets or geosynthetic materials. These geosynthetic materials allows water to flow through and go into this gravel layer and into the piping or into the piping system. But at the same time, this geosynthetic sheet prevent sand particles or soil particles from being carried by the water into this gravel layer. Okay? That is the function of geosynthetic as filtration. Function number 4 is in terms of drainage. So by definition here, the geosynthetic will act to collect and redirect seepage water within a soil mass or adjacent to retaining walls, tunnel linings, and so forth. Let's say this is a retaining wall and this is the backfill. Okay. And then this is the drainage system, consists of a gravel layer with high permeability. This is a perforated pipe to drain water away from behind retaining wall. Right? This gravel layer is encapsulated by geosynthetic sheets, similar as in the previous case. Right? So by having this drainage system, water in the backfill will flow downward into this drainage system or drainage layer. The presence of a geosynthetic sheet here will allow water to flow into this drainage system, but at the same time, it prevents soil particles from being washed away, which may clog the drainage layer. So by providing this drainage system, the development of water pressure behind the retaining wall can be eliminated. By eliminating the poor water pressure, so there will be no additional lateral force or lateral stress due to water. So that the lateral stress imposed to the retaining structure only comes from the backfill or soil. This photo shows a geosynthetic product which is normally used for drainage. So the black item here, it is called as core, and the grayish material, this is the geotextile sheet. The geotextile sheet normally is porous, so can be used for filtration. Water can flow through, but at the same time, it will prevent the migration of soil particles or other particles. And the black item here provide drainage. The water will penetrate this geosynthetic material and go into the core, and the fluid or liquid will be drained out. The fifth function is containment. This is to contain or to store liquid or gas. Normally, it's used in landfill facilities or in the water reservoir or retention pond. If the geosynthetic materials are being used as a liner in the landfill facility, this geosynthetic material will prevent the migration of leachate to the environment. So those are the 5 major functions of geosynthetic products. There are 2 aims of using geosynthetics. One is we would anticipate that by using geosynthetic product, this product will perform better than the natural materials like soil or rock. The second is that we would anticipate that using geosynthetic material will be more economical than using traditional or natural materials due to the initial cost maybe, or the maintenance costs, and then due to the lifespan or durability. So those are the 2 aims of using geosynthetic. One, to perform better, and second, in terms of cost, to be more economical than using other materials. As I mentioned previously, there are hundreds or thousands of geosynthetic products that are available in the market. But for this course, I divide these geosynthetics into 8 different types. First is what we call a geotextile. Geotextile is a textile in the traditional sense. Normally, it's flexible or porous, and there are 2 types of geotextile. One is what we call as a woven geotextile, and another one is non-woven. This is the woven geotextiles. We can see the fibers are arranged in a regular pattern. This photo shows a non-woven geotextile, so we can see the fibers are arranged randomly. In terms of the application, geotextile can be used as a separator and can be used as reinforcement, can be used as filtration as well as drainage. The second type is what we call geogrids. Geogrid is made from ribs which are arranged parallel, and another set also parallel but these two sets of ribs are arranged perpendicularly to each other, and then there are openings between the ribs as shown in this photo. The usage of these geogrids for reinforcement normally can be used for the construction of road as shown in these two photos. The third type of geosynthetic is what we call Geonet. Some people call it as geospacers. Just like a geogrid, there are two sets of parallel ribs. Instead of perpendicular to each other, it may arrange at different angles. The application of the Geonet generally for drainage. It is called a geospacer for drainage because the configuration of the ribs produce space to allow drainage. This photo shows the view from the top of a Geonet, and then this is from the side. So we can see the parallel rib here, placed on top of another set of parallel rib. Okay, so we can see the space here between ribs, space, and also actually space between the ribs in that way. So if we can see the cross section here, this is the set of parallel ribs normal to the monitor here, and then another set of parallel ribs are placed on top of this set of ribs. So we can see the space here. Okay. Behind this rib also there are spaces. So this Geonet are normally used for drainage. The fourth type is geomembranes. Normally this geomembrane is relatively thin and continuous and can be considered as impermeable, or some people may consider it as very low permeability. In terms of applications, normally geomembranes are being used for the containment of fluid. Right? In the case of landfill facility, can be used as a liner to prevent the migration of leachate. In other application, it can be used to store water here. By looking at this picture, geomembrane can be used in aquacultural farm, where geomembrane is being used to store water to rear fish or ducks. The fifth type is what we call Geosynthetic Clearness or GCL. This GCL normally consists of two sheets of geosynthetic materials. It could be geomembrane, it could be geotextile, and clay materials, normally bentonite, sandwiched between these two geotextile or geosynthetic sheets. If you look at this photo, we can see this is the clay material sandwiched between these two geosynthetic sheets. Geosynthetic clay liners are normally placed at the bottom of this landfill facility to form the liner system, because the geosynthetic materials will provide strength, whereas the clay material, which is sandwiched between these two geosynthetic sheets, provide impermeable layer. This clay material will expand and become impermeable when in contact with liquid or water. The sixth type is what we call geofoams. So geofoams is produced in terms of blocks. So it's a block of planar rigid cellular foam polymeric materials. So the application here is to provide lightweight fill, and it can be used to protect utility. So this photo shows blocks of geofoam. The dimension can be varied depending upon the request from the clients. So this geofoam can be used as fill material, such as those shown in these three photos as fill materials in the highway construction. This photo shows the development on soft clayey soil. And the use of this geosynthetic materials, or the use of this geofoam, replace the use of natural materials such as sand or gravel. These are the schematic diagrams to show the application of a geofoam. Geofoam can be used as lightweight backfill material behind a retaining wall. By using this lightweight geofoam to replace the use of soil as backfill material, will reduce the lateral force exerted to this retaining wall. So by reducing the lateral stress, the dimension of the retaining wall can be reduced, and so that the cost of the construction can be reduced. In addition to that, this geofoam can be used to replace problematic soils. So, for example, here, let's say this house is to be built on a weak soft soil. So the weak soft soil is excavated and replaced by this lightweight material. Then the structure is constructed. So by replacing the problematic soil, which is normally heavy compared to this geosynthetic material, the settlement due to the structure can be minimized or can be eliminated. Another example of utilization of geofoam is to protect utility. If we look at this schematic diagram, let's say we have a culvert here. Instead of using soil as the backfill material, where the soil normally with the density of about 1,800 kilogram per meter cubed, by replacing the soil with this geofoam, which normally with the density of 30 kilogram per meter cube, so the stress exerted to this culvert can be reduced significantly, so that the damage to this culvert can be avoided. On top of this geofoam, other structure can be constructed, such as a road. This is another example where lightweight geofoam can be used to construct embankment for the construction of highway or road. Let's say a road is to be constructed on top of this soft cohesive soil. Instead of using soil to construct embankment, geofoam can be used due to the lightweight of this material. Settlement in the soft cohesive soil due to this embankment can be reduced significantly. The seventh type of this geosynthetic material is geopipes. Some people call it as buried plastic pipes. So this is an example of buried plastic pipes. The last type, or the eighth type, which is called as geocomposites. So these geocomposites consist of a combination of geotextile, geogrids, geonet, geomembrane, and others, which can be fabricated in the factory depending upon the request from the client. The application can be for separation, reinforcement, filtration, drainage, and containment. Okay, those are the materials that I want to share with you in this video. Until we meet again in other videos with different subtopics under geosynthetics. Thank you.